Hi class, welcome back to my backyard. We are going to go through a presentation using Zoom. This is new for me, so hopefully it works. And chapter 8 is on freshwater, but I thought before we actually talked about freshwater, we should just go back and talk a little bit about water itself. So let me see if I can get this to work. I'm going to share my screen. Can you answer the question, why is water unique? What would be your answer? Some of the things, it takes a long time to warm up, it takes a long time to cool down, it evaporates, it condenses. And so in this little presentation, I'm going to go through and discuss a couple of things related to the chemistry of water, and then talk a little bit about the water cycle. So you take a look at the chemistry of water. Water is a polar molecule, and what it means to be polar is that different sides have different charges. So if you take a look, you've got two hydrogen atom, and hydrogen atom, and then you got the oxygen atom on the bottom. Well, it sort of looks like Mickey Mouse, right? It's got two ears and a face, and the ears, because this is a proton, it is positively charged, and you see these little green electrons are negatively charged. So the ears of Mickey Mouse ultimately are a positive charge, and then the bottom or the chin would be a negative charge. And so water likes to bond with other water molecules. They call that a hydrogen bond because, again, the ear of one molecule is going to bond to the chin of another water molecule. And so those bonds can be broken easily, but they also can be formed easily. So that's just a little bit about the chemistry of the water molecule. And now I'm going to take a look at sort of the water cycle. Now, you've seen this water cycle since you were in first and second grade. It's one of the most well-taught science concepts in the elementary schools, but I want to make sure we have a good working definition for each of the terms of the water cycle. So you take a look at evaporation. Evaporation is the change from liquid water into gaseous water. And majority on our planet of evaporation takes place over the oceans. And but that's not to say you can't have evaporation on lakes or the surfaces of rivers. But evaporation is the process where those water molecules that were bonded by a hydrogen bond break apart and then go into the atmosphere. When the atmosphere begins to cool, especially as you go higher in the atmosphere, the precipitation, the bonding again collides, and then those water molecules are together, and that's called condensation. So condensation is when you take gaseous water molecules and they turn into water droplets. Now, water droplets that accumulate obviously are clouds, and if the clouds get large enough, gravity is going to want to pull those water droplets back down to the surface, and that is called precipitation. Now, precipitation takes place over the ocean, which you can see here is in much greater amounts in compared to the precipitation that takes place on the land. Well, that precipitated land water is now going to do two things once it hits the surface. One, it's going to run off. It's going to go into rivers and streams. It's going to flow across our parking lots. Or two, it's going to go down into the ground, and that is called infiltration. So infiltration really is the start of groundwater processes. And as you can see with the infiltration, it too moves under the influence of gravity along with river systems, and it goes and moves from a higher elevation to a lower elevation. Ultimately, the base level or the lowest elevation is our world's oceans. So that's just a brief sort of overview of the hydrologic cycle. I will be making another video that takes a look specifically at groundwater. But you can think of these as storage units. And so I just want to go through and take a look at the storage units. This is a graph that is in our textbook in different forms. But obviously, the vast majority of water fauna on our planet is saltwater. And it's the biggest storage unit. 97.2% of all water is housed in our oceans. And then that water ultimately, as rivers move in and water is evaporating, has a balance of, a little bit extra salts. So you can consider the oceans as salty. And then this 2.8% here represents freshwater. Now, if you look at the next pie chart, the vast majority of freshwater on the planet actually is locked up either in Greenland or in Antarctica. So those are the two largest glaciers found on our planet. And then groundwater is the next largest amount. And groundwater is something we're going to need to address and talk about because we continuously use it and it's not getting recharged as much as it's being taken out of. You can see then here we've got freshwater lakes and saline lakes and soil moisture and stream channels in the atmosphere are all a very small portion of the water that is found on our planets. So hopefully this gives you just a little bit of an overview, and make sure to go and read chapter 8 on fresh water.